actually find out, well, what is x going to be? Sometimes it's easy. If you have a calculator, a to the third power equals the answer. If all the numbers are on the same side, you're done. But if x is floating in the air, and that's what we're going to do today, we're going to try and get that answer. Don't write on that new sheet yet. Don't write on that new sheet. All right, so here we go. Do me a favor. Write down, questions on how to write this guy.
No.
Please write E and F in exponential form. This sheet is a mixed sheet, so the x isn't always going to end up in the same place. So be careful. How do you do it? Find the base. Can anyone remind me while you're writing, how do we know that this 8 is a base and this 8 is a base? There's a way to know. The rule I told you about the base. I use a house analogy.
The house analogy.
This is why I'm asking you not to eat up all the prompts, because on the next class I need to say the same thing. So some of you are like, oh, shoot, I remember you said that. Anybody know how I know 8 is the base here, or 8 is the base with the log?
It's placed.
Right.
Yeah, like in below.
Right, Carlos is saying, you are always the base if you're below someone. This 8 is below the 3, so he's a base. This 8 right here, he's kind of below the x, below the g. As long as you're down low in the basement of the house, then you are the base. Can 3 be a base? No. He's not below anybody. Can x be a base? No. He's not below anybody. You need to be below someone to be a base. All right, try to write this side. Please tell me the exponential form of this log.
X squared equals 81.
X is the base, so you always write the base first, then switch. Base, and then switch.
Yay!
No big deal. I mean, I'm a super teacher because logs can be kind of tricky. F on this side, someone please say it.
X to the 4 power equals 81.
X, I'm going to try and get over here. X. And switch. Base and switch. Now, let me say this to you. There are some math teachers who will be upset at you if, when they ask you to rewrite a log, you say base and switch. Because technically, you don't know what's going on. It's just a teacher telling you exactly how to do it. Let me say it real one time. Then we'll go to our sheets, and we'll still do the fake way and then get a real answer. The official way we're supposed to say this thing is the log and exponents are inverses. That is, they're opposites. To get rid of a log, you need to raise something to a power because they're opposites. So like division and multiplication are opposites. To undo multiplication, you do division. Well, to get rid of a log, you have to do an exponent. So officially, to solve this one, here's what you do. You need to raise this log, you need to make the log a power. In other words, this 2 here, I'm going to make it the base. So now I'm raising 2 to a power. The power is log. As long as there's a power and a log, they're going to cancel each other out. So here's the long, ugly way. 2 to the power of log. Whatever you do on the left side, you must do to the right. 2 to the power of x. You do them just like that. These 2 technically cancel. This log 2 and this big 2, they're going to cancel out, leaving just the 128. And this side, you're left with just 2 to the x. That is the official way that you're supposed to explain why the log disappears. But me, instead of saying make 2 the base and raise it to the power of log, which is the official way, so you will have heard it once, I just like to say write the base and switch. By writing the base and switch, even if a student isn't good at math, anybody can write a base and switch. And so part of what I want is you first to be able to get the answer, and then second, eventually, when some math teacher explains to you why, you're like, oh, okay, that's why it works. Okay, whatever. But I can still write base and switch.
We copy this down, right?
You don't have to. This side should already be done. But here's what's also true. This is not the final answer. In the end, they're going to say, well, so what is x? What is the power that when you raise 5 to it, you'll get a 625? Or they'll say, well, what is x? What is the power that when 2 raised to that power will give you 128? And then lastly over here, well, what is x? What is 8 raised to the 3rd power? But all of these you cannot get if you can't change from log to exponential. With that said, let's do one more easy on. Only take this one, and then we'll start solving. On that new page that I gave you, The very first problem, that whole first section actually, first I'm going to have you write on the side that this is going to be standard 3. So stand 3, let me see where can I write stand 3, so that you know when it's time to study for your test. The first 4 are going to be standard 3. You can check in the back to see if it's back there. Let me see if I can see. So if I were doing it, the first 4 would be standard 3. I don't have much space here. I don't know how you're going to write it. And actually I need to give you some scratch paper because the amount of work that you need to do to actually get these answers will not fit in this space. So I'm going to put here, not standard 4 because there is no standard 4, standard 3 actually. Stand 3. Step 1 with stand 3. You can write it directly below here and then put it on the line where it says exponential function. Please write just the first one. And again, these are going to be baby problems, so yeah, the answer is going to be obvious to some of you. Don't be too happy about that, because in the end, they're going to make it a little tricky. Do me a favor, please write the first one in exponential form, base and switch, base and switch. All right, so they did practice with logs. They did practice with logs. The logs, now we're going to use this logs to help you imagine things. The problem was what log of base 4, 16, and it equals the x. Now you rewrote that, very nice, log and switch. So far everybody's a genius, everyone's getting standard 3, only 3 standards. You got your x up there, you got your 16 over here. I'll ask it, if it came out this easy, I would probably still ask you to show the steps, which we're about to do. But anybody know what power you raise 4 to get a 16?
X.
Right, 2. And I know what you mean, I know what he means. So it's perfect. But it's true. 2 is the power that if you put a 2 in the place of the x, you get a 16. Here's the official way when the numbers are big and crazy. The x is a balloon, it's floating in the air. What could we tie onto a balloon to make it come down? A rock is good, even though because of the section that we're in, use the word stick is good.
The log.
Thank you very much. A stick was good, a rock was good, a tire, that would have been great. All right, in any case, if you need to get the x down from the ceiling, or from the attic, or from floating in the air, you need to tie a log to it. Now, this only works if the x is floating above. Sometimes the x will be down below and you'll write the word log, you'll be wrong. It only works if the x is floating above. So how do we do this? I didn't give myself enough space in here, and you probably don't have enough space either, so I'll do it as is. Here comes step 1. To get the x down, officially you write L-O-G. You tie that log to the front. This is the official way. This is what you'll need to show on your test as you do it. In math, we know what we do to one side of an equal sign, we must do to the other. That's standard. So if I divide on one side, I got to divide on the other. If I write a log on one side, I have to squeeze in a log in front of this 16, which, again, I wish I would give myself more space. So how you're doing is I could see on the board, if you're getting your notes, and hopefully you write standard 3 on here somewhere. The last move you're going to do is...
Oh, you pull log in front of 16?
Just like it is on the board, This, by writing this log in front, whatever exponent is floating in the air can come down, which is what we need. So this x goes in front. The log 4 is still right there. The log 16 is still right there. I may even show you a shortcut on this version on the next time we do it. Last step to get x alone, x times all of this equals that. Well, when you multiply x times something, what's the inverse of multiplying? Does anyone know?
Dividing.
Yeah, dividing. So just like old school, once the x comes down because of that log, you can do regular old division. And we wind up with x equals a log 16 over a log 4. I'm going to remind you of the steps in just a moment once we have them all there. Sometimes writing and hearing, you don't get a chance just to see it. Log 16 divided by log 4. Now, some people would think this means, hey, just do 16 divided by 4, and that's 4. But that is not correct. The log actually does something there. And so, let's pause here for a moment.
Wait, so why is there so much space in between the X? Like,
Oh, just only because I wrote it. There's nothing special there.
oh,
Yeah. So if you were to put it right next to it, you wouldn't be wrong. All right. While some of you are writing, let me just remind you of the pattern, and then we'll get the final answer right by plugging in into the calculator. Step 1: if X is in the ceiling or floating above like a balloon, tie a log to it. That is, write the word log in front. What you do on one side, you must do on the other. By putting that log there, it brings the X down. I almost want to write an arrow there. I almost want to write an arrow there so that on the next line you see that the log has in fact come down. Where are you? There you go. So the log did in fact come down. To solve for X means get X alone. Well, whatever is next to it, X times that. Well, you divide that on both sides. And then from there, the last step, calculators please, You need to find the log button in there. Please do. Log 16 divided by log 4. This is the most famous log. If you get one like these where the X is floating in the air, that's the one they will show you most of the time. The new stuff that I will show you probably next class will become slightly confusing or whatever, but guess what? If you get this easy version, you have most of them. Let me jump so that when you do the second one, I'm going to have you do the skip method. Skip method simply says this. I'm going to rewrite the same problem. Let's see if I can bring it down a little bit. So that when you see this, you can skip. Now, for those of you who are like, whoa, that skipping thing was too fast for me, you do not have to skip. You can just do this nice and easy. But for those who will see what's going to happen here, it will happen the way I'm going to show it every single time. So we have our log for 16. I'm going to start off the same way. I'm going to write my base. My base and switch, no big deal. Everyone's a genius with base and switch.
thank you.
So from here is what I want to say to you. If ever you need to solve this equation here, which we just did, there's a fast forward method that simply says this. Well, you can watch it and then you can write it. Step 1, if X is in the ceiling, you're going to circle it. If it's in the ceiling, you circle it. Then you're going to draw an arrow. This is the fast version of this. You just have to recognize whenever you see it, you can do this fast version. How do you know it's the fast version? X is in the ceiling. It's in a balloon floating up high that you need to tie a log to. There it comes. I circle the X, and I draw an arrow from the 4. Circle and arrow. Every single time, it will work out this way. That circled X will remain on the left side. That 16 and that 4 will wind up on the right side, all by themselves, as a division problem. Take a look and see if you can follow what it is. I'm going to add in the word log twice, and I'm ready to get my answer. This is the fast version. This is the version that you need to hear after you know officially what's happening. You write the log, the X comes down, you divide the log on both sides. That's the long version. This version, circle and arrow. The second time that you do it, I'm going to try to get you to do the circle and arrow method, which is shorter. It's faster, but the bad news is some math teachers won't like it because, let me write in green, you write log on the top, log on the bottom. Take a look at it, see if you're confused. Now, does this work every single time? Yes. Every single time the X is in the ceiling, circle, arrow, voila, it's a division problem with the word log in front of them. Here's what I want you to do. The second problem on that page that you're holding there, it starts on the sheet here with the log base 5 of 125.
Yes.
You can switch it on the sheet, of course, because you can have that as a manual short version of it. But then you're going to rewrite it on the second deal over here. I'm going to have you do the short version of it.
Only the shirt.
Yeah, this time, yeah. Let's try with only the short this time, in the interest of time. But to check, see if there's anyone I did not check. This guy was 2, and I'll write it really fast in just a moment.
Second after like
Right. What was that problem? It was log 5?
5, yeah.
125? Okay. Equals to x. Base, I'm keep it all in black. You're supposed to do the colors to make it easier to see, but I think by now people are okay with the 125. Step 2, you always rewrite so that 2 steps are on the same. Circle and arrow. Just that easy. Circle the x, the 125, and the 5. Oops, just long enough. Yes, you must put in the log, otherwise I have to mark it wrong. I know what you mean. Without those logs, sorry, we can't take it. What did it come out to?
3.
3. Take a look at it, pause. Please underline place value. Alright. Each place value is worth 2 to the x, where x, circle x please, because that's what you're going to need to circle when it's time. Where x is the number of digits to the right of it. They give you this display because it's real life. This is how you get barcodes when you go to the supermarket and they just scan your stuff. Yeah. This is what's going on inside the computer. But in the end, the question is, what is it that you need to know? You need to have the formula, and I'm going to have you rewrite the formula in just a moment. Oh, my space, come on. You need to rewrite the formula. Where I'm going to have you rewrite the formula, I'm going to have you rewrite it, even though our space is going to be limited. I'll have you write it below the thing. Write out the formula, P of x equals 2 to the x. Now the good news here is the minute we see that x floating in the air, we're happy about it. We know that at some point we're going to circle that x and we're going to draw something down to the other side. The problem is we don't have anything on the other side except the name of this function. The name of this function is just p. So if you saw this guy walking down the street like, hey, what's your name? My name is P of x. Yeah. So here's the deal. This line here is the one that's going to help us out. It's going to tell us what to put in the place of P of x. What is P of x equal to? What is he? Let me read. If the place value is 1024, how many digits are to the right of the place value? That's the question asked based on what's up here. But here's what you need to know. In other words, please underline that. In other words, find x, circle the x, we know that's the thing we're going to find, when, this is the key, when P of x equals 1024. In other words, this tells me what to replace P of x with. Write that. What to replace P of x with. Once you know what to replace it with, now you're back to the easy problem. What to replace P of x with. This is the part that someone who's absent today is not going to be able to do. Because you're here, all you're going to want to do once you write that, I'll give you some good chance to write it. For those who are fast writers, you're going to take away the P of x, and you're going to write the number that they gave you for P of x. 1024. Everything else is the same. Now here's the good news for those of you who know the fast version. And I'm going to ask you to try to do it on your own without me doing it. Circle the x and draw the arrow. That part I will do. Circle the x. How do you know circle x? Because in the exponent is floating time. And draw the arrow. And go ahead and try and get the answer to that problem. Begin. All right, I went around the room. Everybody did a great job. They did their x. They did their 1024. They did their 2.
It was hard for me.
They did their log and log. What was the final answer, please?
It was 10.
X equals 10. But since the x was on this side, I decided to keep it consistent. But the truth is, 10 equals actually the same thing as x.
So would it matter if instead of doing it that way?
You are correct. Yeah, as long as everybody who's on one side stays on the same side, it's fine. All right, please do me a favor. Last one. Read the ugly problem right next door to it. And then see if you can set it up. You don't have to get the answer because there's an extra step on that one. Somebody tell me the equation. Somebody tell me the equation to write down, please.
30,000.
The way you know it, there's going to be somewhere a P.
If it was the
You 30,000.
like, oh yeah, you act like that's how I would have said it.
Write that down, write that down. Now here is the problem. Shh. And this is the part that's going to mess up some people on their test. The T is up at the top. We know we're going to circle it. We're going to draw down. The only problem is you only get to circle and draw down if there was just one base connected to the letter T. If this were the only base right here connected to the T, we circle and we draw down. The problem is we got this extra 30,000, and right now we don't even have whatever P is. So I'm going to ask someone to help me there. First, what is the P that they gave us for this problem?
30,000.
I got 30,000 here, so I wonder about that.
4.5.
It's going to be this 35,000 over here. And the reason we kind of know that eventually they're going to say somewhere in there that P equals a certain thing. Let's see, did they say what P is in here? Well, for now, let's just get the pieces together. I'll just put them in. We'll come go back and read it maybe next time. But for now, here comes the 35,000. Another thought for those of you is like, well, that's the only other big number they gave us. My goal here isn't for you to completely understand what this problem is all about. My goal here is this. Once I get rid of the 30,000 by dividing it on both sides, I'm going to be left with just the base and a little red T. When I have just a base and a little red T is when I'm going to circle. And that you should be. Because this is the real deal. The other ones, circle, draw down, circle, draw. Yeah. For the test, they always go, oh, that was easy, you got it? Okay, let's do a whole bunch of stuff to make it confusing. But this will be your example. Step 1, please divide the 30,000 on both sides. Oh, hold on.
Already committed.
Hopefully not in pen. I'm rewriting it again so that you don't see 2 steps on one line. In other words, as a math teacher, when you're writing on the board for students to take notes, you never try to do 2 steps on one line, because when they go back to review it, if there are 2 steps on one line, they're like, how do we get 30,000 on the bottom and a 35 at the same time? Step 1, we got a 35. Step 2, to get rid of that 30,000, we divide it like a regular. There's no log on this division. Hey Thomas, why are we trying to divide this 30,000 anyway?
Why didn't you just commit on the? Why didn't you make another problem?
So it won't confuse us when we go back.
Exactly.
Notes, so we don't confuse. So later on, we can go back and get the steps.
Somebody with a calculator and good answers, tell me what the 35 divided by the 30 is. We need to finish one right away. I'm trying to get to the part where you go like, oh, point, say again.
No, you need to try it though, because what if I wrong?
Somebody say it. We just 2 people can say it.
I got 1.16.
That's what I got.
1.16.
Sixes.
Oh, the 60 is going forever?
Yes.
No.
Just put one last.
Hey,
One last.
no, 16 is there you go.
It's a bad idea, but I'm going to do it anyway. Answer should be close enough to it. Why don't you guys give us a decimal? Well, in any case, fine. So far we have that. Everybody else stayed the same. I didn't do it. The other guy did it. All right, here we go. 0, 4, 5. I keep that T in red. Why is the T in red so important? When you're trying to find something, the exponent. That's how you're using laws.
Just to find 30,000.
I know. That's because people, if you're watching the video, I made a mistake. But guess what? I fixed it.
Yeah.
This is where I was trying to get. Everyone can do this problem from this point. How do I know? The T is up in the ceiling, so I know all they have to do is to circle and draw down.
There's nothing to equal sign.
No, this 30, when we divided it, that part disappeared, and the 35,000 gave us that.
Yeah, you put the one.
So at this point, I feel you can do it.
Why am I drawing this arrow?
This is that other method that I showed, the short
Oh, no, I
method.
can't.
Well, then do the other method where you write the word log in front of each one. That'll be fine.
Okay.
So you'll come down in front of them, and then you'll divide it under.
What's up, bro?
There we go. Circle and arrow, circle and arrow.
1.047.
It's not a bad thing, though.
Yeah, it's supposed to be
Wait, what did you-
1.05.
You gotta about you can pick one.
Equals
Wrong number in.
the red T.
I'm gonna go with the you fixed it already. So.
You must put the LOG. Without the LOG, I must mark you wrong. Sorry about that. I know what you meant, but in order to do this shortcut method, you have to have all the pieces there. And then finally, what did it come out to, like 3.5 something? I'll start with 3.5 if you have some beyond it. I think somebody had 508 or whatever.
Oh, wait, it's got a line. I just cried.
Let's pause and say, hold on, don't.
I fixed it. I fixed it.
All right, let me stop.